Hello students, in this video we are going to see about IPv6 motivation, what are the advantages of IPv6 over IPv4 and the notation we are following to represent IPv6 address. First, these are the topics we are going to cover in Unit 4. We will be starting with IPv6 overview, the core features, addressing mode and how the address space in IPv6. We are going to see about IPv6 packet format, then how the transition is happening between IPv4 to v6, some of the techniques like the tunneling we are going to see, and what are the IPv6 supporting protocols. Start with the motivation. So here the motivation why we are going for IPv6 when you are having v4. The very first reason is uh, the address spaces are not sufficient in IPv4 address space. So we need more number of addresses. The reason is when they have designed IPv4 protocol, they didn't think the internet will scale up to this level what we are having today. With a lot of new computing devices, miniature devices, IoT devices getting connected in internet, it is accommodating more different variety of devices. Though whatever the kind of devices, each and every devices connected in internet should be identified using the IP protocol. So IPv4 address space is not sufficient. So we have to move to the next level addressing. IPv6 has 128-bit address. The length of the address is 128-bit, whereas the length of IPv4 address is 32-bit. And some of the other features in IPv4 is we are not having the fixed header length. Be specifying here. IPv4 header length is a problematic one. Why I'm telling problematic one means, do you know the length of IPv4 header? So by default, the minimum header size is 20 bytes. The maximum header byte is 60 bytes. So within this, the number will be varying. Either it may be 20 or maximum it can be 60, it can be 21, 22, it can be 49, 50, any number. The overhead in the intermediate router is each packet when the router is receiving, it have to calculate the header length and it have to take the decision accordingly, because we are having lot of options included in the header space itself. So each and every option should be processed and accordingly the routing decision a router have to take. So this complexity is still in IPv4. How we are fixing this problem in IPv6 is we are making the header size to be a constant one. So it is only 40-bit length. So the header, there is no problematic at the header router end. Always all the IPv6 header length will be 40 bytes. It knows the length. So accordingly it can take the decision. You may be thinking what happened to the options. Yes, we are not missing those options, but it is handled in a very different way. When I am going to look at the IPv6 header, we will be seeing those things in detail. So simpler management of IPv4 addresses doesn't happen. Security at IP level is not sufficient in IPv4. So we are having various newly added security features in IPv6. Quality of service requirement is not up to the mark in IPv6. Again, we are achieving in IPv6. So these are the motivations why we are moving from IPv4 to IPv6. So these are the advantages. The first one, large address. So you can see IPv4 is having 32-bit, and we are increasing the length to 128 bits. So if you're taking in power, it is maximum number of addresses we can represent in IPv4 is 2 power 32, since the length is 32 bit, but now it is 2 power 128. So the difference is equal to 2 power 96. So 2 power 96 more number of addresses we are adding by using IPv6 format. Just think about the factor, 2 power 96 more number of IP addresses we are adding. So um, the scale of internet. We are not only connecting the supercomputers, server computers, a lot of clients are there, a lot of mobile phones, which they didn't think that these kind of devices will be participating in internet when they designing IPv4. So nowadays we are having mobile phones, miniature IoT devices. For each and every devices, sufficiently we can give the IP address by using IPv6. And flexible header format. So in IPv4 we are having the varying length IP header, and all the routers which is passing the packets are heavily loaded. Heavily loaded in the sense, heavy processing is required at the intermediate router. Like it have to calculate the length of the header, length of the packet. Then it have to look at the options. It have to look at the fragmentation. Lot of such things are there. So each and every router have to check this. You have to check for the checksum error. So a lot of processing is required in IPv6. We have completely removed those kind of processing at the router end. So the switching happens very fastly. Whenever it is receiving the IPv6, minimal amount of processing happens at the router. Immediately the packet is forwarded to the uh, required interface. So the processing work we have reduced in IPv6 addresses by having the flexible header format, and the number of options is limited in IPv4, whereas we have increased the number of options in IPv6. Then we have given the provision for more protocol additions in IPv6. So we have given that much space. According to the need, according to the situation, new protocols may be built, and that can be represented in IPv6 address space. So we have given the provision for that. And support for auto configuration renumbering. The system can choose its IP address without the help of the router. Manually we can configure the thing, which is not possible in the case of IPv4. Support for resource allocation. Resource allocation both at the network level and at the bigger network, so it is supporting IPv6 supporting, whereas none of these features are available in IPv4. So these are the special features of IPv6 addresses. Then we know how the IP address will look at IPv4 format. It will be the number will be like this: 192.168.1.10. So it is made up of 4 sections divided into network ID and host ID. So, but in IPv4, the length of the address is increased to 128 bits. From 32 bit, we made into 128 bit. So, like this, if you are representing, it will be very hot. So, we have moved to the hexadecimal notation for easier understanding of IPv6 address. In hexadecimal notation, the IP address is divided into 8 sections. Just remember, in IPv4 we are having 4 sections. In IPv4 we are having 4 sections. The two each section is they're following the decimal number format. So in IPv4, in IPv6 we are having 8 sections. So just 4 becomes 8, and each section has 4 hexadecimal numbers. It has 4 hexadecimal numbers. Do you know how much space a hexadecimal number will take in terms of bits? A hexadecimal number will take 4 bits. Hexadecimal number will take 4 bits. So this 2 will take 4 bits, 0 will take 4, this 0 will take 4, this 1 will take 4. Combinedly, if we are taking, a section will take, here I will be writing, a section in IPv6 address will take 16 bits. And how many sections we are having? 8 sections. Having 8 sections, 8 into 60, it is equal to 128 bits. So totally 128 bits is the length of IPv6 address. But in a better way, we can just compress the IPv6 address also. Those things will be seen as a separate code. How we can compress the IPv6 address. So in this video, just we started with IPv6. What is the motivation behind IPv6? The very first motivation is the number of addresses available in IPv6 is not at all sufficient. So we have to increase the address length and we have to add more number of addresses. That is the first motivation. The second one is processing is not that much easier in IPv4. Easier in the sense it is not that much fast to support the nowadays network. Lot of overheads are there in IPv4 header processing. We have removed all those overheads in IPv6 addressing format. One of the fundamental thing what we have done is we are having variable header length in IPv4. In IPv6 we made it as a fixed length. 40 bytes is the IPv6 header length. If we want to add more options in IPv6, separately we can add it as a options. Okay? No need to be the part of the fundamental header. The fundamental header in IPv6 is only 40 bytes, whereas in IPv4 it is varying from 20 to 60 bytes. Then in IPv4 packets, we are following the fragmentation, and those fragmentation information should be represented in the IPv4 header itself. Again, we are removing those kind of information in IPv6. Still, IPv6 supports fragmentation, but by using optional headers, not the part of the core header. And security wise, we have improved IPv6. Quality of service, we are giving better quality of service. So to achieve all these things, we are moving from IPv4 to v6. And these are the advantages of IPv6: larger address, extended address hierarchy, flexible header format. Yes, really it is flexible. We are having more number of options than IPv4. We are having the provision to add new protocols to be part of IP, to interact with IP and work along with IP. All those provisions we have given in IPv6. We have given the provision for auto reconfiguration and renumbering. We have given, whereas it is not in IPv4. Support for resource allocation. So these are the special features, advantages we are having in IPv6 over v4. Then we have seen the addressing mode. IPv4 we are having 4 sections. IPv6 we are having 8 sections. And IPv4 addresses we are normally representing it as a decimal number. In IPv6 notation, we are following the hexadecimal number. So this is the hexadecimal number notation of an IP address, and each hexadecimal number will be taking 4 bits. 8 sections. In each section, 4 hexadecimal numbers. So 4 into 16. How much? 4 into 4, 16 bits. Each section is having 16 bits. 8 into 16, totally we are having 128 bits. Okay, thank you.